Hello, and welcome back to another episode of the MARF Files. This episode, I wanted to take a look at the multiple arbitrary function generator, just being a function generator, and kind of bringing it down to maybe its most simplest form as kind of being just an LFO. We kind of rely on the quad function generator, model 281, as kind of our main LFO source if we, put it in its self-cycling mode. Obviously, there is a modulation oscillator that can go in the low frequency range that can provide us with sawtooth, square, and triangle. But yeah, the MARF can kind of do all those things and a lot more. It's kind of the thing I'm never really actually using it as an LFO most of the time, because within my system, it's, mainly I kind of use it for sequencing pitches, and which is kind of a bummer because this thing can do so many different things that I almost feel like, oh, I'm cheating myself by just kind of making it do all the pitch work so often, and it makes me think about, I think there's a saying with the make noise maths, which is kind of a dual slope generator, kind of a 281, kind of a surge thing, where there's a million different things you can do with it. And then some people kind of get into option paralysis of well, do I just use it as an LFO? That seems like the lamest way to use the thing because it can do so many other things. And it's both of those are true at the same time. Use it for what you need in the moment. So while I'm not using it for LFOs very often, when I do and actually try and pull out all that I can from this thing, I have a good time. It's fun. Okay, so where do we start with this? I'm going to let's see here. I'm going to set up just this sawtooth oscillator on the 285. I'm going to actually have this this set up to where I'm having some preset of pitches that's going to go into this oscillator, so we'll hear that now. So that side is going to kind of take care of just changing the pitch instead of us listening to a static pitch over and over. So we're kind of going to we're going to focus on the function generator to the right one. So what I'm going to do is set up on this first stage. I'm going to set a first stage modifier in the operating mode, and I'm going to go over to the second stage and put the last. I have it set up for the time range to be in the 0.2 to 3 second time range. And then if I press start on our clock, we can see that we're kind of alternating back and forth. So now we're going to use this for our low pass gate first. So I have this going in low pass gate C on the 292. And basically what we're going to first start off doing is leaving our stage 1 low, and we're going to move up our stage 2, effectively giving us a square wave LFO. I can change the time multiplier to slow that down. So yeah, pretty straightforward, right? But actually, what is kind of tough is just to find square wave LFOs in a Buchla system. It's we can get it from the modulation oscillator, but sometimes that's running at audio rates and it's not just available. with the attack and decay, you can kind of, on the quad function generator, you're kind of just dealing with angles most of the time. You can kind of bridge two function generators together to kind of clock one or the other, and then have like your attack and decay down all the way. And I think you set it to the held stage, and then it's like the CV out of this. When it goes high, we plug it into here, it'll then, this function generator will go high and then low as it kind of lowers through that threshold. So sorry, tangent. Anyways, here's just a square wave that we've got, but we can add our slope function to the second stage and hear what that sounds like. So now we have like a saw wave kind of ramp that's happening. What we can also do is add a slope to the first stage. So now both these are slopes, and we're getting a triangle. We can also, now we have like a falling ramp. So there's our kind of main LFO forms. But what is kind of cool is, we have more outputs. And one thing I'll kind of go into now, one kind of trick I found out a while back, which is pretty cool, is that if you turn the external source for the time range section, it works differently than the way the main output voltage works with its correlating time sliders and output. So if we were to put like an external source into, or have this functioning, we have it on, actually let's put it on stage 2, and we're going to play. So it's going to read, so we have this low, right? So we're not hearing any voltage because it's not opening up the low pass gate. And then this is trying to read the internal input of D right now, right? And we get nothing because we have nothing in here. Makes, sense, right? But what's different about the time range is that the time output just reads kind of where the slider position is, and then takes all these other kind of things into account for like the actual timing. Then that's kind of like what's connected to the clock. So if I put a external input source on these two, and then I press start, if I were going to move these up, right, we would think that the time would get slower, but it doesn't, because since there's no voltages that are coming into the external inputs, it's reading nothing. So what do we get? We can flip this over to our time, and we're back to getting like a square wave because we've got a high and a low. So we could effectively kind of have a triangle LFO going up here, and also getting the square wave at the same time. We can still change the time with the multiplier and the time range. So we still have a lot of flexibility as far as our timing goes. But yeah, we just now have the availability to use a secondary output. So with this, I could go, let's see here. I'll just put I've got the 258 first running into this MEMS and Associates 291 that I just got built up, and so I'm going to have now the triangle LFO go into the center frequency. So I'm kind of going to narrow the bandwidth. So now you can hear that triangle kind of working with that a little bit. I'm going to actually turn this down and just... That's what the triangle's doing. One other thing that I haven't mentioned yet, compared to using this as an LFO, and compared to, like I said, like using the a modulation oscillator or the 281, there's nothing to change the voltage level of those. Like if you cycle a 281, you're gonna get it's gonna go from 0 to 10 volts and drop back down. And same with the modulation oscillator. What's cool with using the MARF as an LFO, you have control with the sliders to affect how much voltage you're going. So I keep on kind of putting the second voltage all the way up, right? Like all the way to the top. So we're getting kind of 0 to 10 volt swings, but we don't have to. So if I kind of switch back. So here's back to our triangle, and but I can move the slider down to like halfway, and we're not fully opening that low pass gate, which, that's, I don't know, the thing that always kind of boggles my mind about the 292 is that there's not and I guess it was kind of changed with like the 292E, and you have an extra input. But something to, all these, any CV that's going to go into it, it has to be kind of attenuated at the source, because there's no attenuator on the input. So it's kind of nice, if you're using it in like low pass mode, and maybe you don't want the full swing, which sure sounds great, but you also get cool sounds when it's attenuated a bit, because that kind of quack of this low pass gate, usually I find it kind of happens at like the 3/4 way up right there. So you can kind of have an LFO that messes around just with that area. It's kind of nice. Okay, so we've got this kind of multifunction LFO. We can set it with the slopes into kind of any form that we want to, or with these slopes. So, and then we've got the secondary time output that we can use as like a square wave. And actually just show you, we can do that same thing. We don't have to go all the way up. And we can also mess with the first stage, right? We can make it so it doesn't go down to 0 volts. So we can kind of set it up into weird, as if we were kind of had the low pass gate open a little bit. But then, check it out. We also have the reference output. So, the reference output is it's kind of like the pulsar on a music easel. Basically, with every step of the MARF, it will give you like a down ramp that is the entire length of that stage's cycle. So, I'll put this into the reference. So you can hear it's kind of going double time compared to if we use like the main output. That's because we have two stages that's going. So it's kind of effectively like we hear it trigger here and trigger here. So you get this double time kind of thing. So what we could do, let's put our, square wave Or actually, no. Let's do that there. I have like longer chords than I need. I've turned down the wave shape on my oscillator. I'm going to put that the time output in there, and I'm going to go to our reference to mess with the center frequency. Actually, maybe I'll switch this around. So I'm going to go my main output into the filter, and then my reference going into the 292. So, kind of a cool way, like, if you're just going to dedicate one side of the MARF to be an LFO, at least you can get 3 different outputs from it that are kind of doing, you can set up to do different things. Another cool thing that we can do is actually we can use the external input to kind of give us a variable LFO. So obviously we can kind of vary the LFO. Let's say if we, let's see here, I'm going to trigger this stored random voltage. We could be messing with like the time of this. I kind of didn't show that. If we have, let's say we're using this in this external mode where it's not reading our time sliders, and yeah, setup basically going into the time multiplier CV input, we can kind of mess with the time to get kind of wonky shapes. We can speed this up into like the super fast mode. Kind of gets a little bit more fluid there when it's running at really high rates. Okay, now to get back to what I was going to show you. So what we could do instead, let's take this fluctuating random voltage and let's stick it into B. So now I'm going to go back to this triangle wave being our main output into the 292, and I'm going to put the second stage into external. So once again, kind of when I showed you in the beginning, we're now missing out on that. We have to, there's no voltage that's going to come out of the slider because we have it in this external mode, and so it wants us, it's looking now at these inputs. So if I go to B, I now have a LFO that is being affected by, its amplitude is being affected by this fluctuating random voltage. So instead of like when I was talking about, oh, you can kind of mess with the slider to get to minimize the voltage a bit, I'm doing that with CV. So I can speed this up. All while you're still getting your square output from the time, and I took out the reference, but that could still be in there as well. So yeah, so really flexible LFO if you want to use your function generator that way. I mean, you know, that's kind of like the thing that I wish we had in this day and age is there's the extension for the MARF that Roman initially put out, that is a 16 stage slider extension, which I don't think was ever a thing in Buchla. The real extension had actually, I've got a photo of it. I'm gonna put it up here. You can see up top there, that top row, it gave you, yes, another 16 sliders, but it also gave you 4 function generators. And the whole idea is, like, if you got something like this, you could effectively, have so many function generators in there that you don't need any other envelopes, like the 280 or 284 or 281. You could have you could use all those extra outputs and sliders to make, to do more functions. Like I said, like I kind of use this mainly as a pitch sequencer. If I had more functions and more sliders, you could definitely dream up a whole lot more ways to use this all at once while doing your pitch sequencing and things like that. So, a guy can dream and cross his fingers that somebody someday will recreate that, because that's the way that I would like to work with this system. But yeah, hope you enjoyed this. Maybe try this out. If you come up with any cool ways to use this as an LFO, please let me know. And don't sleep on this external input. Like, if you're not using your time sliders within a patch, and you kind of just have a set time that you're using, and you're not using your external inputs, that's a big thing too. Put this into the external mode on all your stages, and then you have an extra set of control voltage that's going to come out of your time that will be in time with whatever else you're doing with your MARF. If I have sequences that I'm using, sometimes it's nice to have, kind of have preset voltage for like the wave shape, or I'll do panning things with these voltages, and or run these into the attack and decay of the function generators I'm using to have kind of specific lengths of attack and decay envelopes, if that's what I'm using it for. So lots of things that you can do with this. Really cool. They're a little bit more gritty compared to the voltage that's coming out of here. There's a lot more noise. So you can use them for pitch, but it's like they're not quantized. They have the full range, so you really gotta like dial things in really acutely. I've done it, but it doesn't sound great. So heavily filter that stuff. Use short envelopes, and you can kind of get things to pass. But definitely don't sleep on this, and I'm sure in future episodes I'll be pointing this out quite a lot. So once again, thanks for watching.